everybody? How was your night? And how are you doing? Welcome to this morning class. Okay. This morning we'll be talking about trigonometry. This morning, you are all welcome. When we say trigonometry, trig is we apply trig every now and then, in terms of measurements. So let's know the meaning of trigonometry before we begin to solve any problem. Trigonometry, this is a branch of mathematics which deals with circular measure and trigonometrical ratios as the ratios of sides of a right-angled triangle. Talking about acute angle, right? Okay. So this is the definition, should in case you are asked to define trigonometry. Is that clear? So this is the definition. Take note. This is the definition. Take note. So now, let us, because we are going to solve examples and also we prove identities, trig identities. Very important in this, as long as this course is concerned. You know very well that let us have our right angle triangle. Amen. Okay. This is a right angle triangle. This is theta, right? Let's name here this point A, and let us name this point C. Amen. This point B. So you know very well that this is the longest side of a right angle triangle. True or false? It is known as what? Hypotenuse. Then this is adjacent side. It is known as just like the distance between the ground and a ladder. So this is known as what? Adjacent, and this is opposite. True or false? True, right? Please listen very attentively because it will help you. Is that clear? So as you can see now, this longest side is the distance, which is r. Then here is our x. Then here is our y. I know some of you don't know why here is x and here is y. I'm going to explain it, right? Let us have a plane. If we have a plane like this, can you see now? You know, in plane, we call this side, this is vertical, this is horizontal, true or false, in plane. So, in plane like this, you know very well that your x is always here, then your y, is the vertical axis. Can you see now? So by the time we now have considered the distance, we can now see that we have a right angle triangle. That is why x is always fixed here and y is always fixed here. Do you understand? Are you following? Are you following? Okay. So if you can see what I am saying, let's begin to consider this. So now it means this is how this right angle triangle is. Yeah. This is y x r, right? That is a b c. Yeah. Are you following? So now we are going to apply Pythagoras theorem here. When we apply Pythagoras theorem, it means Pythagoras theorem states that the longest side, this is the longest side, the square of the longest side, that is the square of the longest side, it means what is here? R. R square is equals to the square, the sum of the square of the two remaining sides, that is talking about this and this. So it means x square plus y square. This is a Pythagoras theorem, mathematically stated here. So now our r will now be equals to square root of x square plus y square. Amen. That is why you come across arrow is always equals to a square root of x square plus y square. Do you understand? Are you following? Okay. So far so good. So as you can see now, you don't need a prophet to tell you. So now let us try to recall. I'm just trying to explain. Let's try to recall Sokatoa. Amen. Sokatoa, right? Okay. Sokatoa. You know, when we say Sokatoa, Sokatoa means sine. This so equals to sine theta. Then this is equals to what? This is O means opposite, H means hypotenuse. Are you following? Do you understand? So it means opposite over hypotenuse. Opposite all over hypotenuse. Is that clear? Then Ka means cos theta. Is that clear? Take note, please. Ka means cos theta. So look at it here. A means adjacent. Then H means hypotenuse. So adjacent all over what? Hypotenuse. Okay. Then when you look at it, adjacent is what? R, right? Opposite is y, right? So y all over r. Then here is sorry, hypotenuse is r. Adjacent is look at it x, right? X all over hypotenuse is r. Do you understand? Any question before I proceed? Do you have any question? Any question? Any question? Yes or no? Okay, you people are following. It's okay. It's all right. Oh, Tessie, he said the last part. Yeah. We are talking about Sokatoa. I said so means sin theta, which is opposite all over hypotenuse. O means opposite. H means hypotenuse. Is that clear? So that is why we have opposite all over hypotenuse. So it means sin theta is always opposite all over what? Hypotenuse. When you look at the two right angle triangles, you don't need a prophet to tell you this is hypotenuse R, this is adjacent X, this is opposite. Look at it. So that is why you see y all over r. Then Ka means cos theta equals to A means adjacent. Look at it here. H means hypotenuse. So adjacent is x. This is x all over hypotenuse r. Do you understand, Tessie? Are you following, Tessie? So far so good. So The last but not the least is tan theta, tan, that is TOA. TOA means tan theta. This is opposite all over what? Adjacent. True or false? Then this is equals to opposite is what? Opposite is y. Then adjacent is what? X, right? Okay. Yeah. So before we begin to do any proof or any other thing, we must take note of this. So now let us write them out. Let's define them very well, properly. Is that clear? So this means that sine theta is equals to y all over r. So now go back to your two coordinate system, talking about Cartesian system and polar system. So if now you want to find the Cartesian system, you know the Cartesian system is Cartesian coordinate is always x, y, true or false. So if now you want to find from polar to Cartesian coordinate, if you want to convert from polar to Cartesian coordinate, it means by the time you cross multiply, it means your y will now be r sine theta. True or false? Then if r is given, you just substitute, you get your y. Then here is, anyway, we are not talking about that. I'm just trying to recall and remind you, true or false, is something we have done last one week or 2 weeks thereabouts. Okay? Excuse me. So our cos theta is equals to x all over r, right? The same thing applicable here. Then our tan theta is equals to y all over x. True or false? Is that clear? Okay. Do you understand? Any question? Do you have any question that you want to ask? Any question? Any question? Yes or no? Do you have any question? If you have any question, please ask. If you have any question, ask. Excuse me. No question, so we can proceed now, right? Okay. So let us take note that sec theta is equals to 1 all over cos theta. Then let us just take note of all these things. Is that clear? Then cosec theta is equals to 1 all over sin theta. Take note. Then cot theta is equals to 1 all over sin theta. Take note. Is that clear? Sorry, tan theta. Take note, these things are very necessary and very important because we want to prove some identities now. We want to prove some identities. So they are always important. Is that clear? Are you following? Are you following? Do you understand? And let us always note that our tan theta is always equals to Yeah. Our tan theta is always equals to sin theta all over cos theta. Please take it. Excuse me. So by the time you substitute this and this divide, you arrive at this again. Take note. So let us consider some identity. Let's consider some identity. Is that clear? Then likewise, cot theta is equals to cos theta all over sin theta. That is a tan inverse. Yeah, tan inverse. Please, if you come across something of this form, don't get confused. This is the same thing as sin inverse theta. So please take note. Take note. Is that clear? So let us begin to prove some problems. Let's prove some identities. Any question before we begin to prove identities? Any question, yes or no? Do you have any question? No question. Okay, let's proceed. Let us proceed. Let's proceed. Okay. So now say prove that example. Prove that cos square theta plus sin square theta equals to 1. It's simple as ABC. It is not difficult. So what we need to do here is let us write a solution, or let's just write proof. Yeah. So what we need to do, our cos square theta plus sin square theta is equals to 1, right? So what we need to do, they said we should prove that this is equals to 1. Prove how we obtain this equation. It's simple as ABC. So let me just show you guys. So if I were you, go back to draw your rectangle, triangle. Yeah. Theta. This is a y arrow x. Point A, B, C. Alright? Okay. Yeah. So far, so good. What we need to do here is let's go back to our identity. Sorry, SOHCAHTOA, right? You know that cos theta is equals to what? Adjacent all over x all over arrow. Then sin theta is equals to opposite, that is y all over what? Arrow, right? Two of us. So as you can see now, you don't need a prophet to tell you. So what you need to do is let us have our right angle, let's recall our Pythagoras theorem. Two of us. Yeah. Let us recall our Pythagoras theorem. That is Pythagoras theorem. It says r square is equals to x square plus y square. Two of us. So now what we need to do here is for us to divide through by arrow square. Is that clear? Let us divide through by arrow square. Do you understand? So we now say divide through by arrow square. So this implies that our arrow square all over arrow square equals to x square all over arrow square plus y square all over arrow square. True or false? So, you know, in mathematics, if we have a divide a, this is always 1. True or false? Not to talk of if we have a square all over a square is the same thing as 1. So if we have r square all over r square, this is equals to 1. Is that clear? So here is 1 equals to x square all over r square plus y square all over r square. So let us, please, I don't know whether you have question here. Just drop your question. If you have any question, drop it. No question? Okay. There is no question. Let's proceed. So we can write this in this form. This is x square all over r square all over r square plus y square all over r square is the same thing as 1. That commit any offense? No. This and this, they are the same thing. Just that we try to rearrange it orderly. So you know very well that if we have a square all over b square, take note. This is the same thing as a all over b all in bracket square. True or false? True or false? It's true, right? Okay. So far, so good. So let us transform it in this form. X all over r, open bracket, close bracket, all in square. It's the same thing as this. Plus, because by the time you apply your indices, you get back the same thing. Then plus y all over r, all in square is equals to what? 1. True or false? Yeah. So far, so good. So as you can see, if you can see what I am saying, let us now go back to SOHCAHTOA, where you know that cos theta is x all over what? R. And sin theta is y all over what? R. True or false? So, what do we have here? Ask yourself. X all over R, right? X all over R is what? Cos theta. Cos theta. All is square plus sin theta is that is y all over r. Look at the y all over r is sin theta. So sin theta all in square equals to 1. Then, you know, let me tell you, as long as trigonometry is concerned, trig identity is concerned, you don't need to, if assuming we have sine a all in square, close bracket square, you cannot write it this way, sine square a square. No. This is wrong. Take note. Is that clear? As long as trig is concerned, this is wrong. As long as trig is concerned, it means this is how you are going to write it. Sine square a. Sine square a. Take note. Are you following? Do you understand? Do you understand? Hope you are following. So take note. So at this point, what we need to do is, here will be what? Cos square theta plus sine square theta. established the proof. This established can you see now? So they want us to prove to have this. So with this, you can prove to have this. Any question before we proceed? Do you have any question? No question. So it means we can proceed, right? Is that clear? Yeah, so let's move to consider another examples. Yeah, show that okay, yeah. Let us consider another examples. Let's consider another examples. Let us also prove. Let's prove that 1 plus tan square theta is equal to sec square theta. Is that clear? Sec square theta. So let's prove by using the Pythagoras theorem. Are you following? Using the Pythagoras theorem. So let's prove r square is equal to x square plus y square. True or false? Amen? So at this point, we are going to divide 2 by x square. So divide 2 by the other one, we divide 2 by r square, right? Divide 2 by x square, amen? So it means r square all over x square is equal to x square all over x square plus y square all over x square. True or false? True or false? You may likely see questions like this. Yeah, in the exam. So this and this cancel, always 1. So r square all over x square is equals to 1 plus y square all over x square, right? So this is the same thing as r all over x, open bracket, all in square equals to 1 plus y all over x, close bracket, all in square. Yeah, go back to your SOHCAHTOA. We know that tan theta is equals to what? Y all over x. True or false? So this is tan theta. Then let's come back. We know that sin theta is equals to x all over r. So now the sin inverse the sin inverse, which is it means this is sin inverse if we write r all over x if we write r all over x, it means this is 1 all over sin theta. So now, what is 1 all over sin theta? Cosec theta, right? True or false? Cosec theta, right? Sin inverse, true or false? Student. True or false? True or false, student? Cosec theta, right? True or false? True or false? Okay. Let's move to have the basin first. Okay. Yeah. So here is tan. Then here we are going to have cosec theta. All is going to equals 1 plus. This is tan theta, right? This is tan theta. True or false? Okay. So it means cosec square theta is equals to 1 plus tan square theta. Let's forget about proof. That is, if you come across that show that either 1 plus tan square theta, because sometimes you might see it in this one, 1 plus tan square theta is equals to cosec square theta. Show either in this one or this one, they are all the same thing. Is that clear? True or false? Any question? Any question? Okay. So now let's consider another identity. The first one we divide through by r square, then the second one we divide through by s square. Let's divide through by y square. Okay? So let's prove another one by r square equals to x square plus y square divide through by y square. So here will now be r square all over y square, which is equals to x square all over y square plus y squared all over y squared. True or false? It's true, right? So this cancel. Give us r squared all over y squared equals to x squared all over y squared plus 1. So let us go back to our, what is it called? We know that sin theta is equals to opposite all over, which is what? Y all over r, right? Yeah. Then cos theta is equals to x all over r. Then tan theta is equals to y all over r. True or false? So now here, when we have y all over x. So if we have x all over y, it means this is tan inverse. True or false? Tan inverse. True or false? Look at it. Look at this. Then, if we have y all over, r all over y, it means this is a sin inverse. True or false? True or false? It's true, right? Yeah. This is sin inverse. Where is r all over y, sin inverse. What am I trying to do? Yeah, is this? Yeah, it will give us this y inverse. Y all over, okay? Okay, so I'm right, yeah, I'm right. True or false, please? So, here will now be, this is a sin inverse, and the sin inverse is cosec square theta equals to, this is tan inverse. Tan inverse is what? Cot theta. Okay? Let me also break this one down. Cosec theta all in square equals to, here is tan inverse, and tan inverse is cot theta all in square, then plus what? 1. So far so good. This is the same as cosec square theta is equals to cot square theta plus 1. So whenever you are asked to prove that either this is equals to this or this is equals to this, this is the procedure you are going to follow. Is that clear? Any question? Please, do you have any question? Do you have any question? Let us consider some proofs. Again. Okay, let's consider some examples. Prove that 1 plus cos theta, 1 plus cos theta, open bracket, close bracket, times 1 minus cos theta is equals to 1 all over cosec theta. As simple as ABC. So what we need to do here is write proof or solution, whichever one. So this means 1 plus cos theta, open bracket, 1 minus cos theta equals 1 all over cosec square theta. So what you need to do is use this to multiply this. So let's multiply. 1 times 1 is 1. 1 times minus cos theta is minus cos theta. True or false? It's true, right? Then cos theta times 1, here will be plus cos theta. Then plus cos theta times minus cos theta, we are going to have minus cos square theta, which is equals to 1 all over cosec square theta. Amen? Amen. Okay? So far so good. You don't need the prophet to tell you this and this can go. Two of us. So 1 minus cosec cos square theta is equals to 1 all over cosec square theta. Note that this is what? This is sin inverse because 1 all over sin theta is the same thing as cosec theta. True of us. Okay, so now let's go back. Let us note that cos square theta plus sin square theta is equals to 1. True or false? So this implies that our sin square theta is equals to 1 minus cos square theta. True or false? So can you see what I am saying? You don't need the prophet to tell you. True or false? It's true. Yeah, it's true. So with this, the proof has been what? Established. Yeah. With this, the proof has been what? Established. Because we know that our 1 all over sin theta. Okay. 1 all over sin square theta is the same thing as cosec square theta. The proof has been what? Established. So, do you have any question? Any further question? Any question? Yes or no? Do you have any question? Do you have any question? Let's consider the example. is prove that tan theta plus cot theta is equals to sec theta times cosec theta. Cosec theta, right? Okay. So now, what we need to do is note that our tan theta is always equals to sin theta all over cos theta. True of us. Yeah. Then, and our cot theta is equals to the inverse of tan cos theta all over what? Sin theta. True of us. It's true. So when you look at it, you just substitute this here. So therefore, our tan here is sin theta all over cos theta, right? Plus cot here is cos theta all over sin theta. True of us. And this is equals to sec, okay? Sec theta times cosec theta. If you can see what I am saying, look at it very well. You don't need a prophet to tell you. So now, this times this, we take the LCM. This times this, we have sin square theta plus cos square theta. True of us. The left hand side is cos theta times sin theta. Amen. Any question? Please let me check whether there is question. Do you have any question? Yes or no? No question? So, as you can see now, go back to your trig. You know that sin square theta plus cos square theta is equal to what? 1. So it means this is the same as 1 all over cos theta times sin theta. True of us. It's true, right? Okay. So far, so good. So, what else? We know that 1 all over cos theta, cos inverse is what? Sec theta, right? Am I right? Then 1 all over sin theta is cosec theta. True or false? True or false, student? It's true, right? True or false? It's true. So, as you can see now, look at it very well. Yeah, as you can see now here, this is this, this is this. True or false? It's true. So, by the time you substitute in this, if you can see what I'm saying, because now our tan theta plus cot theta is now equals to 1 all over cos theta times sin theta. True or false? True or false? Because we are trying to prove that the right hand side, the left hand side is equals to sec theta times cosec theta. That is what we are trying to do. And when you look at the question, look at it here. So, if you can see what I am saying, it means Instead of this, we write 1 all over cos theta times sin theta, which is equals to what? This is equals to sec theta times cosec theta. Then cos theta is the inverse. You know that when we have 1 all over cos theta times sin theta, this is the same as 1 all over cos theta times 1 all over what? Sin theta. True or false? It's true. So here means what is 1 cos inverse? Cos inverse is sec theta. So sec theta times what is sin inverse? Is cosec theta. Cosec theta, which is equals to, you can now see that the left hand side is equals to the right hand side. So this established the proof. So that is that. This established the proof. So let's take one example. Let us take one example. Let's take one example. Let us take one example. Let's consider one example. Okay? Continue, right? Please, in this example, you'll be the one to press your calculator. Then I'm going to score you the fastest 5-3 persons. Very important. Example, if sin theta equals to 1 all over 3 and theta is accurate, find the value of all the other trigonometrical ratio. All the other trigonometrical ratios. It's simple as ABC. Is that clear? Let's look at it together. It's not difficult. We write solution. What I will advise you, all the trigonometrical ratios, we have sin theta, cos theta, tan theta, sec theta, cosec theta, cot theta. True or false? Yeah. Yes. So how can we manage to obtain already? Sin theta has been given as this, and this. As simple as ABC is not difficult. Is that clear? So what we need to do here is, let us go back to, note that our sin theta is 1 all over 3. So let us have our right angle triangle. This is okay, theta, right? So SOHCAHTOA. So means opposite all over. Recall your SOHCAHTOA is very important at this point. So opposite all over what? So that is sin theta is equals to opposite all over hypotenuse, right? Which is equals to, this is our opposites. So here is 3, here is 1. Then this is our R, this is our Y, this is our X. It means our X is unknown, right? X is unknown, true or false? So when you come across something like this, you don't need a prophet to tell you. What you need to do, first recall your Pythagoras theorem. Pythagoras theorem is r squared equals to x squared plus y squared. True or false? True or false? True or false? It's true. You will see this type of question in your exam. It's very important. Take notes. So at this point, where r equals to 3, y equals to 1. So, 3 squared equals to x is unknown, right? X is equals to unknown plus 1 squared. So we are going to look for what? Our what? Let's look for x, right? So x squared will now be equals to 3 squared minus 1 squared. True or false? So our x squared, okay, let's square both sides, will now be equals to 3 squared, square root of minus 1 squared. X squared is equals to what? Is equals to 9 minus 1. True or false? This is equals to square root of 8. Then this is the same thing as square root of 8 is 2 root 2. True or false? True or false? It's true. Square root of 8 is equals to square root of, apply sub here. This is equals to root 4 times root 2. Then what is square root of 4? Square root of 4 is 2 root 2. Yeah. So our x here is 2 root 2. Do you understand? So this is our x, 2 root 2. So now let us proceed to consider already your sin theta is given as 1 all over 3. Then let's consider cos theta, because all the trigonometrical ratios, which is SOHCAHTOA, is very important. Yeah, adjacent all over what? Hypotenuse, right? So what is your adjacent? Adjacent is 2 root 2 all over what? 3. That is, it means our cos theta is equals to 2 root 2 all over 3. Do you understand? Do you understand? Are you following? Are you following? Do you understand? Okay? So now let us also consider tan theta is equals to opposite all over adjacent, right? Then this is, there are so many ways you can solve this problem. At first you can use sine or cos squared theta plus sine squared theta equals to 1. Then you substitute in the values. Since sin theta is equals to 1, then your cos square theta plus 1 all over 3 all is square equals to 1. If you solve it this way, you still arrive at the same answer. So, all the same. So, now, what we need to do here is opposite all over adjacent, right? So, what is opposite? Opposite is 1. Then all over adjacent is 2 root 2, right? So, our tan theta equals to 1 all over 2 root 2, right? But in sort, as long as we have something like this, it is not proper, so we have to transform this, we rationalize this. So this tan theta will now be equals to 1 all over 2 root 2 times 2 rationalized all over root 2. Can you see now? So what we need to do is our tan theta now be equals to 1 times 2 root 2, this is 2 root 2, then 2 times 2, 4, and here, then 2 root 2 times, yeah, this is what you are going to get, 2 of us. So, you don't need the prophet to tell you. This and this will cancel to give us root 2 all over 2. Then, square root of 4 is 2 times 2. This is equals to root 2 all over 4. Am I right? Am I right? Okay. So now let's recall. Let us recall. Let's recall. What is our sine? What is sine inverse? If I may ask. Oh yeah. What is sine inverse? What is sine inverse, so student? Sine inverse is cosec theta, right? Then cos inverse is sec theta, right? Two of us. And tan inverse is equals to cot theta. So we have gotten this, and sine, two of us. Sine theta is given as what? 1 all over 3, right? So now, listen here. If we want to find cosec theta, right? I hope I'm right. Am I right? Yes. So if now we want to find cosec theta, what is our sin theta? Our sin theta is given as 1 all over 3, right? Here will now be 1 all over 3 equals to cosec theta. Then, if you can see what I am saying, this is 1 divided 1 all over 3 equals to cosec theta. So by the time you convert this to multiplication, what are you supposed to have? What are you supposed to have? you are supposed to have 1 times 3 all over 1 cosec theta, which is, this implies that cosec theta is equals to 3, right? True or false? And what else? I'm trying to off this. Then, what is our sec? Let's find sec theta. Sec theta, which is equals to 1 all over cos theta. What is the answer of cos theta? I think cos theta is, I think we have 3, 1, 2, 2, right? Cos adjacent all over cos theta is adjacent all over 2, 2 all over hypotenuse. Okay? Yeah. I think this is so our excuse me, our sec theta is equals to 2 root 2 all over 3, right? Oh, sorry. 1 all over 2 root 2 all over 3. Then we are going to do the same thing here. Our sec theta now will be equals to 3 root 2 root 2. But I told you that if we have something like this, mathematics, it is not proper because of the sort here. So we have to transform it. We rationalize it to 3. Hope I'm right. Because here we're going to give you 2 root 2 all over 3. Then by the time you turn this one plus, this one will come out. Okay. Hope I'm right. Am I right? Am I right? Yeah. So here, let's finish it and call it a day. Here will always be 2 root 2 times 2 root 2 all over 2 root 2. Then this will going to give us, this is 6 root 2 because 3 times 2 root 2 all over 4 root 4, right? Then this is equals to 2 to itself 2, 3. Then 3 root 2 all over, because here will be 2 times square root of 4 is 2, right? So sec theta will now be equals to 3 root 2 all over 2 times 2, 4. True or false? That is sec theta for you. So then let's consider the last but not the least is 1 all over tan theta, which is equals to cot theta. Then this is cot theta is equals to 1 all over our tan is what? Root 2 all over 4, right? True or false? So we have to, what we do? Here will now be 4 all over root 2. Then because of the sort, you rationalize. When you rationalize, what are you supposed to have? So, try and rationalize it. If you rationalize it, you are going to have root 2. Yeah. Okay, let's do it together. Times root 2 all over root 2. This is 4 root 2, then all over, this is root 4, right? Then this is equals to 4 root 2, all over what? 2. This and this cancel. So our cot theta is equals to 2 root 2. Yeah. So this is how you are going to solve this type of questions. So in case you come across it in your exam, I don't think you'll find it difficult. If and only if you know what we have been doing all through. But if you don't understand, drop your question in the comment section. Please don't forget to share. Don't forget to share this video. Thank you and God bless you. I wish you a wonderful day and weekend. Love you guys. Don't forget to share. Bye bye. Yeah, I said we are going to call it a day. So if you don't understand, drop your question in the comment section. I'll get back to you. And please don't forget to share this video. I love you guys. Please don't forget to share it on your Facebook page or any platform. Is that clear? And please try to take note of all these things we have done so far. I wish you a wonderful day and weekend. Love you. Bye. Thank you all.